Okay, so this is the first video in our scale factor unit, and the purpose of this is kind of just an activity to just kind of give you some hands-on experience with using scale factor, and so that it actually means something to you when a question's saying scale factor of 3 or scale factor of 10 or whatever it is, that you have kind of a real life situations that you can think about to how to apply that. So for this project, you're going to use a starburst wrapper. If there are none available, a candy wrapper of some sort or something, around the size of that, which would be like 1 inch by 2 inches. That kind of size would be good. So I took the time to measure this, for an example, but in real, this is not the measurements of an actual starburst wrapper. So you'll need to do your own measurements. So the length I got was 6 centimeters for its length, and then 3.8 centimeters for its width. And those are my original dimensions. Okay, so this is my real life starting off. This is what the wrapper was. Now our first task is to get a piece of graph paper, graph paper, and create a scale drawing with a scale factor of 3. So if there's a scale factor of 3, it just means that your drawing is 3 times bigger than the real life version, than your original version. So if it's going to be 3 times bigger, then we're just going to take our initial measurements. So our original measurement was 6 centimeters long and 3.8 centimeters wide. So we're just going to take those and multiply them by 3. So 6, so we're just going to take both those things and multiply them by 3. So 6 times 3 is 18 centimeters, and 3.8 centimeters times 3 would be 11.4 centimeters. Okay, so this is now our new dimensions. This is what we would draw to make a version that is 3 times larger, a scale factor of 3. It asks here if this new image that we're drawing is a reduction or an enlargement. A reduction just means it's getting smaller, and an enlargement means it's getting bigger. Okay, exactly what it sounds like. So in this case, if it's getting 3 times bigger, we would call this an enlargement. So I'd write enlargement here. Okay. So I found my measurements, so that now I'm going to go to my graph paper, and this was my original one here, and I would then measure with my ruler and measure it. I said my measurements were like 18 by 11.4 centimeters, I believe. So I would take a ruler and I'd measure out 18 centimeters, and I'm just going to eyeball this one, but for the sake of time. So 18 by 11, and so let's say it's like this. Okay, it's about 3 times bigger. Okay, and in real life, you'd make your lines nice and straight with the ruler, measure them exactly, and so on. And I would label this task 1. Okay, not a bad idea here to label as well that this was like 18 centimeters by 11.4 centimeters. And our original one here was, we said 6 centimeters by 3.8 centimeters. Okay. So then that is all I have to do for task 1. Okay. Task 2 is a little bit, it's the exact same idea, except that this one has a scale factor of 1/2. So if something has a scale factor of 1/2, the new drawing is going to be half as big as the original. So we're actually not doing anything different here. We're still multiplying by the scale factor, but we're multiplying by 1/2. Multiplying by 1/2 is the same thing. You can think of it as a couple different ways. We could think of it as multiplying by this as a decimal. If you were to find this as a decimal in your calculator, you would just say 1 divided by 2. The top divided by the bottom. 1 divided by 2 would be 0.5. So this is really the same thing. If we're multiplying by half, it's the same thing as multiplying by 0.5. So we would still take our original dimensions of our very, very first one. Okay, so our original dimensions we said were 6 centimeters and 3.8 centimeters. And now we're going to multiply by our scale factor again. So for this new drawing, we're multiplying by 1/2 or multiplying by 0.5. Either way will work just fine. And it will 6 times 0.5 would give me 3, and this one 3.8 would be 1.9 centimeters. And then I would say this one is a reduction because my new image is going to be smaller, and I would draw this on my graph paper just like I did the last one. The task 3 is no different, except it is talking about a scale factor of 3/4, okay, or 3/4. So 3/4, again, you could think of this as like we're multiplying by 3/4, which is completely correct. An easier way to think about it also might be to think of this as a decimal. Okay, to find this as a decimal, you'd say 3 divided by 4, your top divided by bottom, and that would tell you that this is the same thing as 0.75. Okay, so we'll take our original, our 6 and our 3.8, we're going to multiply by our scale factor, which is 0.75. Okay, 3/4 means the same thing as 0.75. And this one is also going to be smaller. It's going to be 3/4 of the size, so we just call it a reduction. Now, this one is the same idea, but it's writing it in a different form. Okay, this one is saying our scale factor is 3 to 2. Okay, it's telling us the ratio. Ratios we can also rewrite as a fraction. Okay, where we take the first number, that's the number that goes on the top, and the second number is the one that goes on the bottom. Okay, so if you got that confused and wrote 2/3, okay, this one would be incorrect and would not give you the correct answer. Okay, ratios always say if you're going to rewrite them as a fraction, it's always the first number that goes on top and the second number that goes on bottom. So if we were going to write this as a decimal, we'd say 3 divided by 2, and that would tell us 1.5. So this 3 to 2 is really just another way of saying a scale factor of 1.5, or that it's going to get kind of like 50% bigger. So that's all we're going to do to find out our new dimensions here. And the very last one, this is just scale factor of 2, so you're just multiplying by 2. There's nothing super tricky about this one. But for this last one, I want you to actually add some extra detail. Okay, so I think about 10, 15 minutes or so of like extra detail where you're not just drawing the rectangle, but you're actually going to draw the details of this on there as well. It's more important that you get the details that you draw exactly correct than getting every single detail on here. Okay, so I'm saying 10 to 15 minutes, not because I think you could do all of this perfectly in 10 to 15 minutes, but because 10 to 15 minutes of doing as much as you can exactly measured properly. So let me just give you an example of like kind of how specific I mean here. So if I was going to draw this this drop symbol on there, the first thing I would need to do is figure out, well, I guess you could think of it in a couple different ways, but the first thing I'm going to do is say how far does this measure off the top here. So it measures 0.5 centimeters away from the top. So I'm going to zoom in here a little bit so you can see better. But this distance here from the top of the wrapper to the top of this is 0.5 centimeters. And my scale factor, SF for scale factor, is 2. Okay, so in my scale drawing, all these measurements are going to be twice as big. So my scale drawing, I would actually have to draw this not 0.5, but twice that, which would be 1 centimeter down. Okay, so it's going to be twice as far down. Where I would start off by just drawing a dot on my scale factor drawing of where that would go. Then I could measure the bottom and say, okay, how far does the bottom go all the way down? All the way down to here, it looks like 2.5. Okay, to go all the way down to there would be 2.5. So I'd measure from the top to 2.5 centimeters, and then I draw a dot there. And then I would say, I want to figure out how wide this is, and I would measure it across there. And it looks like it's about probably 0.5. You know, measure it and be exact, but you can kind of get a couple dots there just to guide your drawing. And then you have a good sense of where this drop is going to go on your picture, and then you can start drawing it out. And it doesn't have to be a beautiful work of art, but it should resemble the size and scale of what's actually on the wrapper. Okay. After that, you could also do the S. You could say like, okay, well, where does the top of the S go to? Where does the bottom of the S go to? So that that is also properly in your picture. Okay. And the idea here is not just to eyeball, but to measure. And because it's a scale factor of 2, anything you measure, you're going to double for your scale factor on here. So your final product for this is going to have 5 of these rectangles, and then one of them will have 10 to 15 minutes worth of detail put in where you've perfectly drawn those details in the best you can for about 15 minutes. Okay, and then we'll, in the next lessons, we'll do more practice with scale factor. How do we calculate it? Do some more kind of word and number problems. This is just some hands-on experience. So good luck.